Imagine buying a diamond that looks identical, shines exactly the same, has the same chemical structure, and even fools professional diamond testers. Now imagine it wasn't mined from deep underground. It was grown inside a laboratory. It sounds impossible. After all, diamonds take billions of years to form beneath Earth's surface. So how can scientists create one in just a few weeks? And if these diamonds are real, why do some people still call them fake? Today, we're going inside the fascinating world of lab-grown diamonds. Most people think diamonds are incredibly rare. But here's the surprising truth. A diamond is simply carbon, the same element found in graphite, the material inside many pencils. The difference isn't the ingredient, it's the arrangement of the atoms. Inside a diamond, carbon atoms lock together in an extremely strong three-dimensional crystal structure. That's what gives diamonds their famous hardness, sparkle, and durability. Deep beneath Earth's surface, enormous heat and pressure force carbon into this crystal structure over very long periods of time. Eventually, volcanic activity brings some of those diamonds closer to the surface where they can be mined. Scientists wondered, what if we recreated those conditions ourselves? Today, there are two main ways to grow diamonds in a laboratory. The first is called high pressure, high temperature, or HPHT. Imagine placing a tiny diamond seed inside a machine that recreates the crushing pressure and intense heat found deep inside the Earth. The machine subjects the seed to temperatures of around 1,300 to 1,600 degrees Celsius and pressures reaching several gigapascals. Carbon dissolves in molten metal and gradually crystallizes onto the seed, making it grow larger over time. The second method is called chemical vapor deposition, or CVD. Instead of extreme pressure, this process starts with a thin diamond seed inside a vacuum chamber. A gas containing carbon, often methane mixed with hydrogen, is introduced into the chamber. Powerful energy such as microwaves breaks apart the gas molecules. Carbon atoms separate and slowly settle onto the seed, layer by layer, atom by atom. The diamond grows. Once the diamond reaches the desired size, it's removed from the chamber. But it's still far from becoming the sparkling gemstone you see in jewelry stores. Expert cutters study the crystal carefully. Every angle matters. A tiny mistake can reduce both brilliance and value. Using precision laser equipment, they cut the rough crystal into smaller pieces. Then, skilled polishers shape each facet until light reflects perfectly inside the stone. The famous sparkle isn't created by nature alone. It's created by craftsmanship. It's almost like growing a crystal, except every new layer forms genuine diamond. Here's where many people get confused. Lab-grown diamonds are real diamonds. They have the same crystal structure as mined diamonds. They are made of carbon. They rank the same 10 on the Mohs hardness scale. They can often be graded using the same standards for cut, color, clarity, and carat. Specialized instruments can sometimes identify differences in growth patterns or trace elements, but to the naked eye, and even to many standard diamond testers, they can appear identical. The biggest difference isn't what they are, it's where they formed. One grew underground, the other grew in a controlled laboratory. If lab-grown diamonds are real, why do they usually cost less? Unlike natural diamonds, which depend on geological processes and mining, laboratory production can be expanded over time. As manufacturing improves and more companies produce them, supply increases. That greater availability has contributed to lower prices for many lab-grown diamonds compared with similar natural diamonds. Some buyers value the geological history and rarity of natural diamonds. Others focus on appearance and performance. Which matters more depends on the person. The next time you see a sparkling diamond, ask yourself one question. Was it formed over immense spans of geological time beneath the earth, or carefully grown inside a laboratory? One came from nature. The other came from human ingenuity. Both are extraordinary examples of what carbon can become. And perhaps the most remarkable part isn't that we've learned how to imitate nature. It's that we've learned how to grow one of its hardest materials, atom by atom.